Hello everybody and welcome to the Carlam Cymru revision sessions. My name is Alexa Jones and I will be presenting this session focused on the intermediate tier maths and numeracy GCSEs. The session will last around 45 minutes. If you have any questions, please use the question and answer section within this live event and I will do my best to answer your questions. The session will be recorded and the recording and any relevant resources will be uploaded to the e-sgol website under the Carlam Cymru tab. Okay, so today we are going to be having a look at standard form. So let's start off with a reminder. I'm going to need to pause the video. Because I'm talking on video, you are going to need to pause the video and try the questions and then start it again. So I'm not going to pause very long for you to try some questions. You are going to need to pause the video and then start again when you're ready to see some answers. So just as a bit of a warm-up exercise, see if you can write these numbers 10 squared, 10 cubed and 10 to the power of 5 as ordinary numbers. So if you'd like to pause the video and then start the video again as soon as you're ready to see the answers. Okay, so let's go through these. Now, the first one that we have here is 10 squared. So 10 squared means 10 multiplied by 10, and 10 tens are 100. So 10 squared is 100. 10 cubed means 10 multiplied by 10 multiplied by 10 again. So I've got 3 tens multiplied together. And that 10 multiplied by 10 is 100. Multiplied by 10 again is 1000. 10 to the power of 5, well, I'll have 5 tens multiplied together. So I've got 10 multiplied by 10, multiplied by 10, multiplied by 10, multiplied by 10 again. And if you notice with these, with 10 squared, it had 2 zeros, 10 cubed had 3 zeros. So 10 to the power of 5, that's going to have 5 zeros. So 1, 2, 3, 4, 5. So that is 100,000 for 10 to the power of 5. And we need to be able to work with powers of 10 in order to do standard form. So standard form then, it's commonly used for numbers that are very large or very small, but any number can easily be written in this form. Standard form uses the laws of indices, but numbers are only expressed in one base, and that's the base 10. So to write a number in standard form, we write it in this way. It has to be a number that is between 1 and 10. So a number between 1 and slightly smaller than 10 multiplied by 10 to a power. And that power can be positive, as in this first example, 6 multiplied by 10 to the power of 5. And a positive power would indicate to me that this is a large number. But the power can also be negative. So we could have something like 6 multiplied by 10 to the power of -4. And that negative power, that means it's a small number. And we'll have a look at that in a little bit more detail to see how that works now. Okay, so how do we write a large number, first of all, in standard form? Well, the first number I've got here is 600, and I needed a number between 1 and 10. So I need a number between 1 and 10 first. So a number between 1 and 10. Well, looking at this, I need 6. I can't change the digits, so I need 6 here. And then I have to multiply that by something. Well, to get to 600, you'd multiply 6 by 100. But we can write 100 as 10 squared. So I can rewrite this as being 6 multiplied by 10 squared. I now have a number between 1 and 10, that's the 6, and I'm multiplying it by a power of 10. So 6 multiplied by 10 squared would be 600 in standard form. So let's have a look at some slightly larger numbers. I've got 4,678, and I need a number between 1 and 10. So a number between 1 and 10, you can't change the digits or the order of the digits, so I've got to start with a 4. So the number is going to be 4.678. Well, what would I need to multiply this by in order to get 4,678? And the answer to that is 1,000. 4.678 multiplied by 1,000 will give me 4,678. But I can write 1,000 as 10 to the power of 3. So in standard form, this number is going to be 4.678 multiplied by 10 to the power of 3. Now, when we get to large numbers, we wouldn't always necessarily have this middle step where we're writing multiplied by 100, 1,000 or 1,000,000, although you can if you want to. What we might do is we might try and go straight to the end step of being in standard form. So when I look at this last one, which is 23,888,000, looking at it to find a number between 1 and 10, I'm going to go with 2.3888. I don't need the zeros on the end because they don't have any value as a decimal, as in 2 point something. Now, what would I multiply that by? Well, let's have a look at the ones that we did here. What we needed to think about with these was we needed to think about how many times we had to move the number in order to get the place value of 6. So here we would need to move the number to put the decimal place here. We would have had to have moved this number twice in order to get the decimal place here. And that's where this 2 comes from up here. With 4,678, I would have wanted the decimal place after the 4. So I would have had to have moved this number 1, 2, 3 times in order to get the correct place value. Now with this one, I want it to be 2.3888. So I would have to move this number 1, 2, 3, 4, 5, 6, 7 times in order for the 2 to be adjusted in front of the decimal point. So this one is going to be 2.3888 multiplied by 10 to the power of 7. Okay, so let's have a go at some of those. So here is an exercise. So if you'd like to pause the presentation and have a go at just writing these 3 numbers in standard form, please. Okay, let's have a look at these. So for the first one, my number between 1 and 10 is going to be 5. And I need to multiply that by 10. Now, the power is going to be, I want the decimal point to be after the 5. At the moment, it's here. So this is 1, 2, 3 places that number would have to move. So this one is 5 multiplied by 10 to the power of 3. For this one, I need a number between 1 and 10. So my number is going to be 2.345. 2.345 multiplied by 10. And this time I would have to move the decimal, I would have to move the number 1, 2, 3 times in order to get the decimal point after the 2. So that is 2.345 multiplied by 10 to the power of 3. Now, notice with this that sometimes people make a mistake and they think that you need to count the number of zeros in order to work out what the power would be. But that isn't the case. If you look at this, that did work for the first one. There were 3 zeros and it was 10 to the power of 3. It doesn't work for the second one because there are no zeros here and it's still 10 to the power of 3. So a common mistake that people will make with the last one is they'll get the first bit right, which is 4.56 multiplied by 10. But sometimes people will mistakenly put down 10 to the power of 3 because there are 3 zeros here. But that isn't how these work. We need the decimal point to be here. So we would have to have moved the number 1, 2, 3, 4, 5 times in order to get the decimal point to be there. So this is actually 4.56 multiplied by 10 to the power of 5. Okay, so that's large numbers. Now, in order to look at small numbers, we need to understand about how negative powers work. So we started looking at powers earlier and we said that 10 to the power of 3 was 10 multiplied by 10 multiplied by 10 again, which is 1,000. 10 squared, we said, was 10 multiplied by 10. It's two 10s multiplied together, so that is 100. 10 to the power of 1, well, there's just one 10 here. So this one is going to be 10. Now, in order to look at these powers, we need to look at the pattern to see what's happening. And you can see that to get from 1,000 to 100, you divide by 10. And to get from 100 to 10, again, you divide by 10. So with these, as the power is going down, as we subtract 1 from the power, we are dividing by 10. So in order to find the next number, we divide by 10. 10 divided by 10 is 1. So 10 to the power of 0 is going to be 1. Now, in order to find the next one, we divide by 10 again. And 1 divided by 10 is 0.1. Let me just change the colour there. I got the wrong colour. There we go. So 10 to the minus 1 is 0.1. And then we follow this pattern down. So 10 to the minus 2 is 0.01. We've divided by 10. And again, 10 to the minus 3 is going to be 0.001. We've divided by 10. This is 1/10th, 100th, 1,000th. Okay, so we need to use that when we are writing small numbers in standard form. So let's look at the first one here. The first one I've got is 0.6. So 0.6, to write a number in standard form, we need to have a number between 1 and 10. So I'm going to need a 6 to start with. Well, in order to get from 6 to 0.6, you'd have to multiply by 0.1. 6 multiplied by 0.1 gives me 0.6. And 0.1, we checked earlier, if you just look up here, 0.1 is 10 to the minus 1. So this one can be written as 6 multiplied by 10 to the minus 1. And if we think about the decimals here, well, we want the decimal point to be here. It's currently here. So we would have to move the number 1 place. So that's where minus 1 comes in. And it's minus because it's a small number. So we're moving the numbers the other way. Now for the next one, this number, I need a number between 1 and 10. So I'm going to go for 8.9. And then I'm going to go straight to standard form. So it's multiplied by 10 to the minus something. I know it's minus because this is a small number. It's a 0.00 something number. So I need to think about how many times I'd have to move the number. It's currently 0.0089 and I want it to be 8.9. So I would have to move the number 1, 2, 3 places in order to get the decimal point in the place that I want. So this is going to be 8.9 multiplied by 10 to the minus 3. For this last one, I need a number between 1 and 10. So it's going to be 9.8. It's always multiplied by 10. And this is a small number, so it's going to be to the power of minus something. To work out what it is, I say, well, OK, this decimal point, I want it to be between the 9 and the 8. So I'd have to move the numbers 1, 2, 3, 4 places in order to have 9.8. So this one is going to be 9.8 multiplied by 10 to the minus 4. Okay, so I have got some questions here for you. If you'd like to pause the presentation and try these, and then when you are ready to see the answers, you could start the presentation again. Okay, let's look at the answers to these. So this first one, a number between 1 and 10, I'm going to go with 9. It's multiplied by 10 to the minus, and I want my decimal point to be here, so I'd have to move the numbers 1, 2, 3, 4 places. So this is 9 multiplied by 10 to the minus 4. For the next one, I need a number between 1 and 10. So that's going to be 3.4. It's going to be multiplied by 10 to the minus, and I need my decimal point to be here. So it would be 1, 2, 3 places I would have to move. So that's 3.4 multiplied by 10 to the minus 3. And then this last one, a number between 1 and 10, I would have to put the decimal point here in order to give me 5.68. Multiplied by 10 to the minus, and I have to move 1, 2, 3, 4 places. So 5.68 multiplied by 10 to the minus 4. Okay, hopefully you've been able to do those. Let's have a look at these ones. So write the standard form number as an ordinary number. So we've been given a number in standard form this time, and we need to convert this into a normal number. So we need to know, is this going to be 734? Is it going to be 73,400? Is it going to be 7,340,000? And that's what we need to work out. So looking at this one, well, what is 10 to the power of 6? 10 to the power of 6, if we just write down this 7.34, 10 to the power of 6, that would be 1, 2, 3, 4, 5, 6. That would be 1,000,000. So this is going to be 7,340,000. Now, one way that people do sometimes think about this is they think about it with the decimal point again, and they think 7.34, and they think, I know that this is a large number, so I know that I need to move these numbers 6 places. I need to move the number 6 places to get the decimal point in the right place. So we'd go 1, 2, 3, 4, 5, 6. So the decimal point should go here, and then we would just fill these in. So this would then become, if we get rid of that decimal point there, it would now become 7,340,000 as an ordinary number. Let's have a look at the next one. So this one, 6 multiplied by 10 to the power of 5. Well, that is 6 multiplied by 10 to the power of 5. Okay, so that is going to have 1, 2, 3, 4, 5 zeros. So that is going to be 6 multiplied by 100,000. So this one is going to be 600,000. And if we were thinking about that with the decimal point, we'd say, well, okay, we've got 6 at the moment, and we would have to move the numbers 5 times. 1, 2, 3, 4, 5. And because the decimal point would go here, we would have to pop some zeros in order to get the correct size. So here we would have 600,000 as our number. Okay, so can you now please pause the presentation and have a go at working these two out as ordinary numbers? Okay, let's have a look and see how you've done with these. So for the first one, if my pen is working, there we go. For the first one, I've got to do 5 multiplied by, and then 10 with 10 to the power of 6. So I've got 1, 2, 3, 4, 5, 6 zeros. So that is 1,000,000. So my answer here is going to be 5 million. Thinking about it the other way, I would be saying, let's start with a 5. My decimal point would be here, and I have to move it 1, 2, 3, 4, 5, 6. So I'd move the numbers 6 times. fill in the zeros. There we go, and that is my 5 million there. So two different ways of thinking about it. For the next one, the distance travelled by a spaceship is approximately 3 multiplied by 10 to the power of 5 miles. Right, this is an ordinary number. So that's going to be 3 multiplied by, and then I need 1, 2, 3, 4, 5 zeros here. So that is 100,000. So my answer is going to be 300,000. And thinking about that the other way, I would be starting with 3 with my decimal point here, and I would have to move the numbers 5 times. So it would be 1, 2, 3, 4, 5 to here, and then I would fill in zeros here, and that's where that 300,000 comes from. Okay, let's look at the next part. So now writing standard form numbers as ordinary numbers when we're dealing with negative powers. So we know now that this is a small number. So looking at this, how would I do this one? Well, one way of doing this is going to be multiplying my 4 multiplied by. Okay, so here we think to ourselves, what would this be? And this would be, so it would be, that would be 1, 2, 3, 4. It would be 4 multiplied by 0.0001. So it would be 0.0004. Thinking about this with the decimal points, you would say, I'm starting with 4. My decimal point is here. And I know that this is a small number. So this time I'm moving the numbers the other way. So I have to move them 4 times. I've got 1, 2, 3, 4. My decimal point's going to go here. Fill in zeros, and then I need a 0 at the front. So that's where 0.0004 comes from. For this one, 4.5 multiplied by 10 to the power of minus 3. Okay, well, 10 to the power of minus 3, that's going to be 0.001. So when I work this one out, this gives me 0.0045. And thinking about this one with decimal points, I would say I am starting with 4.5. I know this is a small number, so I know that I need to move the numbers the other way in order to make this smaller. So I need to go 1, 2, 3 places and pop my decimal point down. And then I need to fill in the zeros here. So it's 0.0045. Okay, so I have a couple of those for you to have a go at now. So there are 2 here. So if you could please pause the presentation and then start the presentation back up again to see if you've got the answers right. Okay, let's have a look at these. So for the first one, I have got 2 multiplied by 0.00345. 1, 2, 3, 4, 5, 6, 7, 1. So I've got 1, 2, 3, 4, 5, 6, 7 zeros. So multiplying those, I am going to get 0.0000002. And thinking about that with decimal points, I would be saying, okay, I'm starting with my decimal point here, and I need to move 7 times. 1, 2, 3, 4, 5, 6, 7 to here, and then filling in those zeros, I can see that I have got 7 in total, 1 in front of the decimal point, and then I've got another 6 after before I get to the 2. For the next one, writing this as an ordinary number, well, I've got 6.5 and 10 to the minus 2 is 0.01. And when you multiply those together, you get 0.065. Thinking about that with the decimal points, I would be saying I'm starting with 6.5 and I need to move 2 places. So it's 1, 2, my decimal point goes here, and then fill in the zeros to make this correct. So it's 0.065. Okay, let's have a look at the next bit. Now here, we're going to change these numbers into standard form. At first glance, you'd look at these and you'd say, oh, they look as though they're in standard form. But actually, none of these are in standard form. And the reason that they're not in standard form are that that first number has to be between 1 and 10. And if you look at the first number here, I've got 45, 0.5, 23 and 0.42. So none of those are between 1 and 10. So I'm going to have to do something in order to change these into standard form. So remember, what we need to be doing is we need a number between 1 and 10. So let's have a look at these. Right, so 45. Now I can write 45 as being 4.5 multiplied by 10. So I can rewrite 45 as 4.5 multiplied by 10, and then multiply that by 10 to the power of 7. But 10 multiplied by 10 to the power of 7 is 10 to the power of 8. So this one can be rewritten in standard form as 4.5 multiplied by 10 to the power of 8. One. Now the next one is tricky. With the next one, what I need to do is I actually need to multiply this 0.5 by 10. So I need to do 0.5 multiplied by 10 in order to get this to being a 5, which is the whole number that I'm going to want in the front. So I need to multiply 0.5 by 10. So I'm going to take one of these 10s here and write it here, which means I've still got 3 of them left. So I'm rewriting this time 10 to the power of 4 as 10 multiplied by 10 to the power of 3. Now 0.5 multiplied by 10 is 5 multiplied by 10 to the power of 3. Let's have a look at the next couple. Make a little bit more room. Okay, so this one, I've got 23 multiplied by 10 to the minus 2. So 23, I need that to be between 1 and 10. So I'm going to write 2.3. So it's 2.3 multiplied by 10. I've rewritten 23 as 2.3 multiplied by 10, multiplied by 10 to the minus 2. Okay, so with this, I'm multiplying by 10 and then I'm multiplying by 10 to the minus 2. Well, that is actually 2.3 multiplied by 10 to the minus 1. If you remember, when you divided by 10, these numbers were going up, minus 1, minus 2, minus 3. So when you multiply by 10, these numbers are going the other way, not going up, they were going down, minus 2, minus 3. Sorry, let's look at it on a number line. So when we were multiplying, so we're starting here with minus 2, when we were dividing by 10, we were going this way, and dividing by 10, it went minus 2, minus 3, minus 4. So these numbers were going down. So multiplying by 10, we're going to go the other way. So multiplying by 10, we would come out to minus 1. For the next one, now with this one, I have to do 4.2, and 4.2, I would have to divide that by 10 in order to get 0.42. And then multiply it by 10 to the power of minus 5. So with this dividing by 10, I am going this way. So if I've got 10 to the minus 5 and I divide that by 10, I would have 4.2 multiplied by 10 to the power of minus 6. The other way that you can do these is you can always write them as a normal number. So if you find that confusing, and it can be confusing, what you can do is you can write them as a normal number and then you can think about them again. So a different way of doing this would be to say, well, if we've got 23 multiplied by 10 to the power of minus 2, let's write that as a normal number. So here I would be having 23, decimal point would be here. It's multiplied by 10 to the minus 2. So I'm going 1, 2. It would be here. So that would be 0.23. Well, of course, I want this to be 2.3. So in order to get to the 2.3, I've got to put the decimal point here. So I've only got to move one place. So that would be 2.3 multiplied by 10 to the minus 1. So with these ones, if ever you get confused with these ones, just write them as a normal number first, an ordinary number, and then go back and put that into standard form. Okay, I'm going to skip these ones because I want to make sure that we get through the rest of these. So there are some questions here. What I'm going to do is I am going to leave those ones for now. When you try this later, you'll be able to go back and have a check and then see the answers. So I will put the answers up later for you. So what we're going to do now is we're going to have a look at multiplying numbers that are in standard form without a calculator. So to do calculations in standard form without a calculator, what we need to do is we need to deal with the numbers and the powers of 10 separately, applying the rules of indices. So here I need to work out the answer to 4 multiplied by 10 to the power of 7 multiplied by 2 multiplied by 10 to the power of 4. And I'm just going to rewrite these into a different order because I think that's easier to see what's going on. So with multiplying, you can write it in a different order because 2 times 3 is the same as 3 times 2. So you're allowed to write them in a different order. I'm going to change this into being 4 multiplied by 2 multiplied by, and then 10 to the power of 7 multiplied by 10 to the power of 4. 4 multiplied by 2 is 8, multiplied by, and then 10 to the power of 7 multiplied by 10 to the power of 4. The rules of indices, when you are multiplying, and they're in the same base 10 here, you can add these little numbers up. So 4 add 7 is 11. So this is 10 to the power of 11. Going back and checking this, do I have a number between 1 and 10? Multiplied by 10 to a power? Yes, I do. So I'm quite happy with that one. You won't always have a number between 1 and 10 here. And then you will have to think again about how to change the number in order to make the number at the front be between 1 and 10. For the second one, okay, I've got a decimal here and I've also got a negative index. So let's have a look at rewriting this one. I'm going to change the order. I'm going to do 2.5 multiplied by 3, and then I'm going to deal with the tens. So I've got 10 to the power of minus 2, and I'm multiplying that by 10 to the power of 12. 0.5 multiplied by 3 is 7.5. Multiplied by, and again, when you multiply these, you can add the little indices up. Minus 2 add 12 is 10. So this is 10 to the power of 10. Okay, so there are some questions here. So can you please work out the answers to these ones? Pause the video, work out the answers, and then come back when you're ready to see the answers. Okay, answers to these ones. So first of all, I'm going to do 4 multiplied by 2, and then I'm going to multiply 10 to the power of 4 by 10 to the power of 15. So my first one is 8 multiplied by 10 to the power of 19. For my second one, 1.5 multiplied by 4. So 1.5 multiplied by 4. And then I'm going to do 10 squared multiplied by 10 to the power of 7. 1.5 multiplied by 4 is 6, multiplied by 10, 2 add 7 is to the power of 9. This one, 2.5 multiplied by 3, multiplied by 10 to the minus 7, multiplied by 10 to the power of 12. 2.5 multiplied by 3 is 7.5. Multiplied by, and then adding minus 7 and 12, you get 10 to the power of 5. Okay, we're going to have a look at dividing in standard form without a calculator now. To do calculations in standard form without a calculator, again, we're going to deal with the numbers and the powers of 10 separately. So I'm going to do 4.4 divided by 2.2, and then I'm going to do 10 to the power of 7 divided by 10 to the power of 4, and then I'm going to put this back together again. 4.4 divided by 2.2 is 2. 10 to the power of 7 divided by 10 to the power of 4. But when you divide, you subtract the little index numbers. So that is going to be 10 cubed. So 10. So putting this back together, I get 2 multiplied by 10 to the power of 3, 10 cubed. Let's try another one of those. So here I am going to divide the numbers first. 7.5 divided by 3, so that's 2.5. And then I've got 10 to the power of 22 divided by 10 to the power of 12. And to do those, you subtract the little index number, so that gives me 10 to the power of 10. Putting this back together, I get 2.5 multiplied by 10 to the power of 10. Okay, so there are a few here for you to do. So can you please pause the presentation and try these and then come back and check your answers. Okay, let's see how you did. So with this one, 8 divided by 2 is 4. And then 10 to the power of 12 divided by 10 to the power of 3, you subtract the little numbers, so it's 10 to the power of 9. 9 divided by 2 is 4.5, multiplied by 10 to the power of, and then 15, 10 to the power of 15 divided by 10 to the power of 7, you subtract the little numbers. 15 subtract 7 is 8, so 4.5 times by 10 to the power of 8. Last one, 4.5 divided by 3 is 1.5 multiplied by, and then you're subtracting the little numbers. So it's 10 minus 7, take away another 3 is minus 10. And if you check all of these, they're all a number between 1 and 10 at the start, multiplied by a power of 10. So I'm happy that all of those are in standard form. But the other thing that you might need to do without a calculator is you might need to add or subtract. Now, in order to add or subtract, with these ones, you do need to change them into ordinary numbers first. So the rule for adding and subtracting is just change them back into ordinary numbers, add or subtract using the column method, and then you may well need to rewrite your answer in standard form. Quite often the question will ask you to do that. So let's have a look at this first one. I've got to work out 4 multiplied by 10 to the power of 5. So that is 4 multiplied by 10 to the power of 5. So with this one, it is going to be, we've got 4, and then we've got to multiply it 1, 2, 3, 4, 5 times. So that is 400,000. So this one is 400,000, and then 2.2 multiplied by 10 to the power of 4. So 2.2 multiplied by 10 to the power of 4. Well, let's have a look at that one. So I've got 2.2 and 1, 2, 3, 4. That one is 22,000. So this one is 22,000. So now I've got these, I'm going to add them up. So I'm starting with 400,000 and I've got to add on 22,000. That gives me 422,000. And now I'm going to write that one back in standard form. So back in standard form, that would be 4.22 multiplied by 10. And then let's just see, the decimal point would need to be here. So it's 1, 2, 3, 4, 5. So it's 4.22 multiplied by 10 to the power of 5. Let's have a look at subtraction. So same thing with subtraction. I am going to write these first of all as normal numbers. So I'm starting with 2.5 multiplied by 10 to the power of minus 2. Well, 2.5, and this is a small number, so 1, 2, that is 0.025. And then the other one that I've got here is I have 3 multiplied by 10 to the power of minus 3. So that one, I'm starting with a 3. It's a small number. So 1, 2, 3. That is 0.003. So this is 0.003. So I'm subtracting. I've got 0.025. Subtract 0.003, and now you can see when you line them up that 5 subtract 3, that's a 2. So I have got 0.022. Now to write that back into standard form, it is going to be 2.2. So I am going to have 2.2 multiplied by, it's a small number, so it's 10 to the minus something. So let's work out what that will be. I need my decimal point to be here, so I have to move twice. So it's 2.2 multiplied by 10 to the power of minus 2. Now, if you are doing these on a calculator, if it comes on the calculator paper, then it's much, much easier because you can just type them into the calculator. And I've got some information here a little bit later on how. So there's some more questions to try. I'll put the answers for those up later. And then I've also got details down here of how you type these into your calculator, what buttons you use. It's much easier if it comes on the calculator. Hello. Sorry, I had some technical difficulties there. I'm not sure quite what happened, so we'll keep going. Okay, so if you are on a calculator paper, all you need to do is to type these into your calculator, whether they're multiply, divide, add or subtract. You would just type them in exactly as they look on the question. And there are some instructions here on how you would do that. So you'll be able to have a look at those later. There are also a few more questions, and then there are some past paper questions below. So there are a few things there for you to have a look at. And those, all the answers for those will be in the information that's uploaded. So let's have a quick look at the things that we need to remember about standard form. So with standard form is always written as a number that is between 1 and 10, and you multiply that by 10 to a power. It's going to be a large number, so it's going to be a positive power for a large number, and it will be a negative power for a small number. When you are working on a non-calculator paper, if you're asked to multiply two numbers in standard form, you can multiply the two numbers together and then you can work out the power of 10. With divide, you would divide the two numbers and then work out the power of 10. So for multiply, you're adding the little index numbers, and for dividing, you're subtracting the little index numbers. When you're asked to add or subtract numbers in standard form, you change them into ordinary numbers first, and then you're usually asked to put your answer back into standard form. For all of these, check the final answer is in standard form. Be really careful that you don't get something like 23 multiplied by 10 to the power of 7 as a final answer. That first number does have to be between 1 and 10. Well, thank you very much for joining us today, and I'm sorry about the technical difficulties, but hopefully we can edit those out before the presentation goes live.